Hi students, today in Algebra 1 we're going to be covering the slope of a line. And you can define slope by it's the ratio of the vertical change relative to the horizontal change. So for instance, if you have a figure that looks like this, and we call our vertical change, we call it the rise. And then we call the horizontal change here, we call that the run. And if we come up with a ratio of rise over run, we call that slope. And to a certain extent, you're familiar with that probably on an intuitive level. I mean, think about if you've ever gone walking in the mountains, and you can see how steep the mountain is climbing relative to the the length of the path, and you can tell that it's if the horizontal distance is small and the steepness is higher. I mean, you can sense that just by looking at it. Also, the same thing when you're riding your bikes or walking upstairs even. This concept of slope comes into play, and really it's kind of a measure of steepness. And of course, in the coordinate grid system, it also tells you kind of a bit of a direction of how your line's going to go. So it's going to describe the steepness of a line and kind of the direction the line is going in. So let's talk about this in terms of a more specific example. All right, so let's look at example 1 specifically. Example 1 in the textbook. And we see a slope represented by this diagram. And we see that what we want to measure is this steepness. And this line right here kind of indicates what the slope is, whereas this right here, this tells us our vertical change, our vertical or rise, and this tells us our horizontal. Now let's say we are given that our vertical rise in this case is 40 feet. Okay, and we're told that our run here is 200 feet, and we're asked to calculate what the slope is going to be. And what we do is our slope is now defined as a ratio. Our slope is defined as a ratio of the rise divided by the run. Okay, so if we're given these numbers up here of our rise being 40 feet and our run being 200 feet, well, what do you think we're going to do? How are we going to calculate that? Well, very easily. We're just going to use this formula right here, and of rise over run, and we're going to put our rise over run, and we're going to say that's equal to 40 feet over, and what did we say our run is? It is 200 feet, as we have here, and so we're going to put that over 200 feet. And so what is that equal to? Well, of course, we're going to simplify this because it's a fraction. We want it in the most simple form. 40 goes into itself once, and it goes into 200 5 times. So our slope becomes 1 over 5, or 1/5. All right, so it's pretty easy to see. Now that we're going to try to do this example, on a coordinate grid. So let's look at the next slide, and I'll show you how that's done. Okay, I'm back. So I have graphed a line here at 2 different points. This point is at 3, 2, and this new system's a little bit hard to use. I got to say, it's not very precise because I'm doing this on an iPad and my fingers are big and this is small, but I'm trying to make this work. The second point is at 8, 4. And the question is, well, what is the steepness of this line? What is, in other words, what's the slope of this line given we have one point at 3, 2, and we have this other point at 8, 4? Well, just like we were saying before, we want to have the change, the vertical change. We want to show what the vertical change is, our rise, relative to our run. Oops, and I'm trying to show that right there. And so we have to see what is the difference between the vertical point between 3, 2 and 8, 4. What is that vertical distance, that change there? And, and then what is the horizontal change that we can see here? Well, that's measured by, we can do that again by, we're doing rise over run, right? And we're going to use this formula of slope equaling rise over run, and it's really kind of our change in, whoops, let me erase this. Okay, over run. Okay. And we're gonna use this formula. Well, what's the difference between, okay, so the y is shows me the rise, right? So I'm going from a point that's like 2 on the y-axis right here. This is at 2, and I'm going up to 4. So what's my change here? It's gonna be 4 minus 2, right? So I've really gone up. I've gone up 2 check marks. And then what's my change, my horizontal change? I'm going from a position of x equal to 3 to a position of x equal to 8, right? So this horizontal distance is really measured by 8 minus 3, right? So that I can say this is 8 minus 3. So what is my slope then? My slope is going to be 4 minus 2, which is 2, over 8 minus 3, which is 5. So my slope of this line means that I'm going to rise 2 blocks. For every 5 blocks we go horizontally. So we go, and let's see if that's true. Do I go up 2, 1, 2, and I'm going over 5. 1, 2, 3, 4, 5. Yeah. So I can see, how that works, and I can see that that's my slope. So this is my rise. That means for every 2 blocks I go up, I am going to go to the right 5 blocks. Okay, so now I think that you're probably ready for a more official formula for slope. So the formula is m, and we use the letter m, and there's quite a bit of discussion out on the internet about why we use the letter m to denote slope, but we do. Some people believe that it comes from the word monter, which means to climb in French, and of course this was invented, the concept, the coordinate grid system and slope and all that was sort of discovered by Descartes, who was French, and so monter means to climb. But then some other people believe it has to do with the fact that the slope was originally called the modulus. That's kind of another word of maybe change, modulus of slope. And so anyway, over time, for whatever reason, mathematicians will disagree, but the letter m has come to denote slope. So when we're doing the formula for slope, we will say m equals, we'll say it's the rise divided by the run. But of course, when we're talking about a, points, ordered pairs in a coordinate grid, we have a much more specific way of looking at what rise is. Rise basically is the changes between 2 points. So it's between the changes in y, we say y sub 2 minus y sub 1. So that will give us our change in rise over our run, which is the changes of x sub 2 minus x sub 1. So these little subscripts really are to denote two different points. And again, when you're calculating slope, as you will discover, it doesn't matter which point you name what. And it doesn't matter which direction, whether you're going up a line or down a line when you calculate slope, because it will be, the slope will be the exact same no matter which point you decide is point number 1, which these coordinates would come from, versus point number 2. All right, so let's take a few examples on the next slide. Okay, so I have brought out a graph of a line that's going through 2 points. One point is going through the x-axis, it's an x-intercept really, and it's going through at point 1, 0. And I have a second point that the line is going through at 3, 4. And what I want to do is I want to calculate the slope of this line. So I'm trying to figure out how fast it's rising relative to how fast it's running, so to speak. So I'm going to get the rise over the run. So I can decide whichever point I'm going to consider my first point versus my second point. And you want to choose the second point to be the larger positive because you want that the ones with the subscripts of 2 to come first. When you're doing your formula, because it'll just make the math easier in terms of negative numbers. So this is larger than this. So why don't we call this? We'll call this right here our point 2, and we'll call this point 1. Although it doesn't matter, and either one would be correct. I'm just trying to do it in such a way that makes the math easier. All right. So what was our formula again for slope? It was slope, which is represented by the variable m, and it is rise over run, right? And the easiest way too, in terms of mnemonic devices to remember this, is rise is on the top, and that when you think of rise, you think of vertical, and you think of the y-axis, and this is the change in y, and then run, you think of, run is on the bottom, you think of your legs there on the bottom running, and then you can think of an X, running with its little legs, okay? So you can remember that run has to do with X. So the formula, as we were saying before, in the coordinate system then is going to be the y value of what we're calling the point 2, minus the y value of the first point divided by the x value of the second point minus the x value of the first point. And as we pointed out, remember, we're going to pretend like this 3, 4 is going to be our second point, and this 1, 0 is going to be our first point. So let's do the math. We're going to do this formula here. And let me see. So let me go back here. All right, so let's look at our y's. We're going from 4, and we're going to subtract 1. So I'm looking. That's the difference in my y's. So let's go and put that in the formula. So that's 4 minus 1. Okay, and now let's do our x's. And our x's are 3 and 1. And we're going from, and that's the key thing. Once you decide this is point 2, that means, this is going to come first in the formula. Both coordinates, x and y, are going to come first. The most classic math mistake is to all of a sudden, put this one first and subtract going in this direction. You got to keep it in the same direction. So 3 minus 1, so that's the same direction as we did the y, 4 minus 0. All right, so let's go put that in our formula. Okay, so that's going to be 3 minus 1. Is that right? Yes, 3 minus 1, and I'm seeing a mistake right here because I'm doing the y's right here. This is supposed to be 4 minus 0. Okay, so let's go back and let's fix that, and we'll calculate this out. So I'm looking at the wrong thing, I guess, here. So this should be a 4 minus 0 and 3 minus 1. So what is our slope? 4 minus 0, well, that's 4 divided by 3 minus 1, that's 2. And then, of course, we simplify it all the way out, and that becomes 2. So what does that mean? Our slope is 2. That means that, and of course we can make this a fraction, right? So that's rise over run. Let's do that so we can look at it. It's like 2 over 1, right? So what we're saying now is that the steepness of this line is 2 over 1. In other words, for every 2 blocks that we go up 1, we're going to go 1 block to the right. And let's see if that's true. Let's go on that grid that, where I drew the line and take a look and see, is our slope 2 over 1? Okay, and I'm going to try to expand this a little bit because it is kind of small. Okay, here we go. So if our slope is 2 over 1, that means I should go up 2 from this point and over 1. Yep, I'm still on the line. And I can go up again, 1, 2, and then 1 to the right. Yep, I'm still on the line. So that is our slope. For every 2 blocks we go up, we're going 1 to the right on the x-axis, 2 up on the y-axis, and 1 on the right, the x-axis. So that's showing us our slope in graphical form. So we figured out how to calculate it using algebra, and we can see by graphing it and looking at it that it is 2 over 1. Okay, so now I want you guys to do the checkpoint that's on the bottom of page 230. There's three problems with 2 sets of points each, and I want you to calculate the slope on it using the slope formula that you just learned, which is, whoops, here, let me shrink that down so you can see it. M equals rise over run, or, what you're really going to be using is this. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And we say sub because this is a subscript, and that's why we say sub. Okay, so let's do that, and I'll be right back on the next slide. We'll go over the checkpoints, and you can check your answers. Okay, so you should have done the checkpoint at the bottom of page 230, and so let's go over your answers, or how you might have done that. So in number 1, you had 2 points. You had 1 point that was 3, 5, and they're calling that your first point. And then you had another point at 1, 4. All right, so slope is equal to the change in y, right? Or your rise, which is denoted by your y-axis. And if we're saying that this is, and let me just do a little note here, we're saying this is point 1, and we're saying this is point 2, and we're going to say y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so that means, let's just plug in. What's y sub 2? Well, it's 4, minus y sub 1, which is right here, 5. Oops, let me put the pencil on. 5. Okay, divided by x. The change in x. So it's going to be x sub 2 right here minus x sub 1. So that's x sub 2 minus x sub 1. And so that's going to be 1 minus 3. And so 1 minus 3. And it's going to be really important that you keep track of these negative signs, especially when you start having negative coordinates. But right now they're taking it easy on you. They're picking just coordinates out of quadrant 1. All right, so what's 4 minus 5? Well, that's a negative 1, right? And what's 1 minus 3? Well, that's a negative 2. All right, so, and I've got 2 negatives now, right? I've got a negative 1 divided by negative 2. I want that in the most simple form, so that's just equal to, negative divided by negative, that's a positive, so this just becomes 1/2. So my slope is now equal to 1/2, and that's the answer for checkpoint 1. All right, so checkpoint 2, I got 2 points. I got one at 2, 0. And they're calling that point 1. And they've got another point at 4, 3. And they're calling that point 2. And we're going to do slope. Okay, we're going to do y sub 2 minus y sub 1. So that's 3 minus 0 divided by y sub 2 minus y sub 1. So that's going to be 4 minus 2. All right, 3 minus 0, well, that's 3. 4 minus 2, that's 2. So my slope is 3/2. Okay, and now we're going to do the last checkpoint. And I've got a point at 2, 7. And I got a point at 1, 3. And our slope is going to be equal to y sub 2 minus y sub 1. So that's going to be 3 minus 7 over x sub 2 minus x sub 1. So that's going to be 1 minus 2. All right, 3 minus 7 is a negative 4. 1 minus 2 is a negative 1. And that equals positive 4. And so that means that my slope is 4, which, if I'm talking about it in terms of rise over run, I'm talking about this really being 4 over 1. In other words, that means that for every 4 blocks that we go up, we're going to go 1 block here to the right.